everybody, I'm teacher Yusen, and today we'll be talking about this challenging question that I've introduced yesterday. So let's take a look at the question directly. The question here says that I have a 3-digit number that is divided by 7, 8, and 9, and the remainders are written on 3 different papers respectively. And now, 3 intelligent and honest children named Adam, Barbara, and Caitlyn. Each of them, they receive 1 paper. And they are only able to see the information that is on their paper. Now, they gave the following statements in the order below. This 3-digit number is not a multiple of 3, says Adam. Barbara then says this 3-digit number must be an odd number. And lastly, Caitlyn says, I already know this 3-digit number. It is a composite number. Now the question asks, what is the 3-digit number? So when reading this question, there are a few important things to take note of. The first thing is that the number is divided by 3 different numbers, 7, 8, and 9. And then each of these students can only see the information that is on their own paper. So they do not know what other students have. And lastly, they gave the statements in order. That means starting from Adam, then Barbara, and lastly Caitlyn. So with that in mind, let's take a look at each of these statements and see what we are able to deduce from them. Starting with Adam, saying that this 3-digit number is not a multiple of 3. So from this sentence, well, what is it that we can get from this sentence? Let's take a quick moment to think about this part. Okay, time's up, everybody. So now, this sentence is very important for us. Well, because it tells us a lot of information actually. Well, when a 3-digit number is not a multiple of 3, let's think. If the number is divided by 7, getting a remainder, can it confirm if it is a multiple of 3? The answer is no, we are not able to confirm whether it is a multiple of 3 or not. Similarly, if this number is divided by 8, am I able to confirm whether this number is or is not a multiple of 3? Similarly, it is impossible to do so. But now, if this number is divided by 9, and if the remainder is not a multiple of 3, what does that tell us? It tells us that this 3-digit number itself is also not a multiple of 3. And hence, from this we are able to see that if Adam is able to say this sentence, he must have gotten a number that is divided by 9. So now, how does it confirm that he got the card that is about divided by 9 then? Is there anything that can help him confirm that he got the card that is divided by 9? And the answer should be very simple. Well, chances are that that's something to do with the remainder that he has obtained. What remainder that he obtained can make sure that he is 100% confirmed that he got the card that is divided by 9? And the answer, of course, is just if he got the remainder of 8. Why? Because, well, if he got a remainder of 8, can it ever be possible that this number is divided by 7 or 8? The answer is, of course, not, because our remainder can never be bigger than our divisor. And hence, we know that his remainder that he has obtained is just going to be 8. So that is all about Adam. Now we move on to Barbara. Barbara says that this 3-digit number must be an odd number. How do we see what does this sentence tell us then? Well, out of the two parts, 7 and 8, let's think. How can we confirm whether a number, well, must be an odd number? Let's think of these cases. When an odd number is divided by another odd number, what are the possibilities of its remainder? Well, if you think about it, it could be either an odd number or an even number. So with that being said, from here, well, we see that when an odd number is divided by another odd number, we do not know what is its remainder. But if we change it up to an even number divided by an odd number, then what do I realize? Oh, I see that when odd number is divided by an even number, the remainder must only be odd. And now we realize, wait, that helps us see what card did Barbara get, which is the one that she got. Definitely the only number that is even, and that is divided by 8. And how did she confirm that she got the card that is divided by 8? Well, similar to how Adam confirmed his, the remainder is just going to be 7. Oh, so now we have a lot more information already. Let's compile this information and see what we can get from them. Now, Caitlyn says, I know this 3-digit number already. And the number is a composite number. Well, from this first, we think, what did we have originally? Well, when this number is divided by 9, it gets a remainder of 8. And when this number is divided by 8, it gets a remainder of 7. So from this, well, we can try to modify it a little bit to make us get a better understanding of what we already have. Oh, we realize that remainder 8 and remainder 7 respectively is just one number away from the divisor. And well, what happens if we add 1 to the original number? Will there be any remainder left? Now, the answer is that no, there will be no more remainder left. And hence, that is what we can get. We add a number 1 to that original number. And now, there's no more remainder. That means it becomes a multiple of 9 after 1 is added to it. Similarly, well, if I add 1 to it, it is also now a multiple of 8. So with that being said, we combine both together. What do we know? We know that this number is divisible by 72 if it is added by 1. So with this information, now let's think, how can Caitlyn know that what is this 3-digit number? So with that being said, we know that this number plus 1 is divisible by 72. But why can she confirm the answer? Well, it must be a unique answer. Then she's able to know what it is. Well, why can she know that it is unique then? How do we know if it's unique? So well, we need to list them down one by one and see which of them stands out as compared to others. And let's try it one by one then. Well, what are possible numbers that are 3 digits and when it's added by 1, it is divisible by 72? Of course, we can just think about all of the multiples of 72. And then I subtract 1. Those are our possible numbers. So let's list them down one by one. 143, 215, so and so on, all the way until 935. These are all of the possible 3-digit numbers that fulfill our previous condition. But how do we see which one of them is unique? It must have something to do with the card that Caitlyn obtained, right? So, well, what did Caitlyn get as a card? She knows that her card is definitely a card that is divided by 9. And well, let's see which of it gives her a unique answer when the number is divided by 7. Alright, so now let's see. When it's divided by 7, what are these numbers' remainders? So here, to save everybody's time, I've listed all of them out for all of you. And here they are. These are the remainders when the above possible numbers are divided by 7. And just now we mentioned that the number must be unique. Which ones of them are not unique? Evidently, if we look at it, we'll see 2 trees on the list. Oh, they are definitely not possible. Followed by, oh, we see again 5, 0, 2, 4. On the right side, we see the exact same 4 numbers. So they are all going to be wrong. So now what numbers are we left with? It's just these numbers over here. These two of them, 503 and 575. These two numbers, if she gets a remainder of 6 or remainder of 1, will tell her that she is able to find the 3-digit number. Now, how do we know which of them is the correct one? Again, we see the question has nicely told us that she says it is a composite number. Well, what is a composite number? A composite number is one that can be divided by numbers other than 1 or itself. Or essentially, we can say that it is not a prime number. Now, if we take a look at 503, wait, 503 is a prime number. So, now what is our answer over here? We see that 575 is divisible by 5, obviously. And that means it is our answer left. So, our answer is 575. So with that being said, with all of this deduction and elimination, we finally get that the answer is 575. Now, let's move on to the conclusion of what we have learned today. So now here, summarizing this type of question, when we get a question that requires this type of logical deduction of numbers, well, the first thing, if they mention this term, already know. What does that mean? Firstly, it requires a basis that the students themselves are very, very smart. They know what is the numbers or the related content. And once they say they already know, it relies on one singular thing. Each of the next person has all of the previous information that the person has said. So, well, for example, in this case, Barbara knows exactly what the person in front of her is saying. Same thing for Caitlyn. And then with that, there is only one single possible answer that is unique. If there are multiple answers that are not unique, the person will not be able to know what is the answer. So that's the first thing that we can conclude. And also regarding our remainders. Well, one important thing is that the remainder can never be bigger than the divisor. And then that's another thing. If I have multiple numbers that divide and get different remainders, oh, then if they all have the same difference, what I can do is just add that same number and they will all become a multiple of the numbers. So with that being said, that is all that we have for our summary. Now, we can take a look at another question that is similar for all of you to attempt. So don't forget, once you have attempted this question. Just write the answer in the comment section below, or if you have any other queries, feel free to join our WhatsApp group, and our teachers at Kangaroo Study will be very glad to help all of you. So with that being said, that's all that I have for today. Don't forget, hit the like button and subscribe to our channel below. Thank you and bye-bye.